I don't think I can share my screen at this point either.
All right, I will change that. There you go. You should be good, Sarah. All right, perfect. So while she is getting set up, I will say hello, everyone that's joining us. Thank you so much for being here tonight with us. My name is Liz DeRozier. I'm an admissions counselor in the office, and we're thrilled to have you here for one of our departmental information sessions, this one specifically for mathematical sciences. And I'm thrilled to be able to introduce our two department heads here, Sarah Olson and Marcel Blaise. And I just a few quick housekeeping things. This is in a webinar format, so as I'm sure you're already aware, you can see us, but we can't see you. And so that's kind of how this is working. And feel free to use the Q&A feature. That's how we're going to make sure all your questions are answered. So throughout the presentation, if you have questions, please feel free to do that. We will make sure to go through them at the end and make sure all your questions get answered, and maybe throughout as well. So with that, I will hand it over to Sarah and Marcel, and good luck, guys. See you soon.
Hello, everybody. So happy to chat with you this evening. So I'll do kind of the first half of the presentation, and then Professor Blaise will take it over. Happy to answer any questions as we go along. So tonight I'm just going to give you a little bit of an overview of our department and some of the activities and kind of what you would learn or get to see while you're a mathematical sciences major or an actuarial science major in our department. So a common question is always just kind of why study mathematics? Some people think that you can only become a teacher, or what are you going to do with your interest in patterns? Or so here I kind of like to just really emphasize that mathematics is really powerful. It's this beautiful language. We can do a lot with math and study a lot of interesting patterns. But if you're drawn to kind of logical analysis or patterns or structure, mathematics would be great for you. Right? It's this language that we use to model and predict, from different applications and perspectives, from biology, physics, engineering. It's pretty much, well known that, mathematics and statistics is going to be the core of modern science. So everything that's data intensive, analyzing that data, understanding the trends. So everything's going to have many potential opportunities with a mathematical sciences or actuarial science major. And here in just this little fun picture, just to show you that, when we think about how things are interconnected and the nodes and the connections, mathematically, we can understand this from kind of the theory, through graph theory, to understand kind of how the connectedness of the nodes and how information could be transferred. So lots of fun applications. So I wanted to just kind of say for a minute or two some other interesting math applications and kind of how this ties into some of our core course material that you would see in the first few years at WPI. So a common example is just an image. And if we kind of zoom in this very pixelated image, what we see is there's actually these little boxes, and each one of those are our pixel values. And in those pixels, we really have data, and that data is kind of the color intensity for these different pieces. But here we have this rectangular grid. The data or the numbers is the variations in the color. And how we can store this information at pixel values is really mathematically what we call matrices. And what mathematics allows us to do is have this language and kind of formulas to understand the data. Right, so each kind of box is an entry in this matrix with the color value. So we can start thinking about these matrices and how to manipulate them, change them, do different kind of functional operations or transformations, rotations. And that's where we start thinking about linear algebra is all about matrices. So this is one of our kind of very common 2000 level courses. that most students take to give you a flavor of the type of mathematics that's presented in these courses. But if we go a little bit further and think about images as functions, we can think about how they map, kind of inputs and outputs. We can think about, instead of just a single value, vectors of kind of these different color variations for red, green, and blue. Then we can think about kind of function transformations or mapping, and we can scale out different colors by understanding kind of the pieces and the different functions. Similarly, we can do rotations. We can really think about how do you de-blur a fuzzy image, sharpening images, image restoration, classifying, or kind of pattern or image recognition, by really understanding kind of how values are changing or the rate of change of these values or gradients. So ties into a lot of things that you would see in a calculus course as well at WPI. Okay, other fun applications kind of going on this matrix and kind of function approximation in linear algebra are things like image reconstruction. We do this in the medical field, with images as x-rays and kind of mapping them all together and doing image reconstruction. Things like facial recognition, really understanding, how to recognize the variations or kind of where the facial expressions are changing, measuring key, characteristics such as distance between eyes. So all of these kind of have really mathematical foundations in terms of how to manipulate that data and understand it. So mathematics is also an entertainment. Things like the movie Frozen and other movies think about, how to in an animation come up with this hair that waves or kind of waves or clouds. And it's actually lots and lots of fun modeling and computation to do realistic hair simulations. Similarly, lots of high performance supercomputers are doing things like animating the Pixar's characters. Okay, so those were some kind of fun examples of where maybe you see math or kind of connecting it to some of our courses. In terms of job opportunities, where we also started, we have different areas of mathematics, which we have courses for, and students getting different jobs in these areas. So we have kind of our standard mathematician or part of our mathematical sciences degree. And students go on to successfully have careers where they're thinking about applying these different theories and formulas. It could be through teaching, it could be through solving problems in kind of industry or different business sectors. Statisticians, we have a mathematical sciences degree, but you can take a lot of statistics courses focusing in statistics, and statisticians are thinking about tabulating, analyzing, interpreting numeric results of experiments and surveys. And then we also have our actuarial science degree, which really thinks about risk and likelihood of future events, often working for insurance companies and thinking about things like property loss, natural disasters, insuring cars. In terms of job titles of recent graduates, one of the keyword is analyst that comes up in just about every job: statistical analyst, risk analyst, quantitative analyst, data analyst. So lots of different job titles, all related to analysts of different types. The American Mathematical Society is a very common society where you can also get some more information. They have some great web pages on different jobs, but kind of the main sectors, as we've mentioned, are insurance, finance, government, research labs, but there's also a lot of positions kind of in healthcare and different consultant companies and banks. In terms of where some of our students have been recently, employed at places like Dell, Hanover Insurance, Cambridge Associates, Fidelity. And then a lot of our students also choose to go on to graduate programs and are very successful kind of with pursuing master's and PhD programs. In terms of what happens when you graduate WPI, if you want to, go into industry or on the job market, WPI employment rates are about 90%. Average salaries are 70,000 or above, and in mathematical sciences, we're slightly higher than the average for mathematical sciences and actuarial science. And math is ranked highly among all of the majors at WPI in terms of initial salary. So a little bit more about our department. So we are a decent sized department with about 40 faculty, a few hundred students. But it's definitely a department full of opportunities, lots of activities, personalized attention and mentoring with faculty, especially through some of the project work that Professor Blaze will go over. Kind of our characteristics are the project-based work, interdisciplinary approaches, teamwork. We have lots of great specialized courses, and especially these research projects that you can take on through the major qualifying project in your senior year. And again, many activities, lots of fun things going on. So here's just an overview of some of the different groups that we have. So we do have different student chapters of societies. So we have one is Association for Women in Math, lots of fun kind of coffee events, lectures, different events, different outreach events that are all going on and kind of bring our mathematical community together. We also have lots of seminar series. We bring people in to talk and share their experiences in jobs and research. So we have, talks from JP Morgan, industry panels. We bring in recent graduates. We have a career and networking event, especially for actuarial majors. And here's a group of actuarial science students who won. This was the 9th annual actuarial case competition, but we send a team just about every year to participate in this. And we also have a student group doing the very famous Putnam exam and all other types of fun activities throughout the year. For the statisticians in the crowd, we also have a student chapter of the American Statistical Association, also putting on additional activities throughout the year. So I already mentioned we have about 200 undergraduate students. We also have very active graduate programs with master's and PhD students, about 40 faculty that you could potentially take classes from, work on research projects with, have that kind of support network. We have our two undergraduate majors, mathematical sciences and actuarial sciences. And then just to also mention, tons of students get double majors or have a minor. So it's also very common, and we're happy to advise on doing these double majors or a minor. Things that have paired well are business, data science, computer science, physics. Now data science is becoming more popular. In terms of what we have going on in the department, we have a large variety of different and exciting things that faculty are working on. And, they bring these different collaborations and projects into the classroom. So we have a professor, Bill Martin, very interested in cryptography and quantum computing. Professor Servatius is very interested in things like rigidity and kind of computational geometry and the interconnections. We have a faculty member who actually, Professor Bernardi, who has a research lab and does microfluidic devices and kind of the math and modeling related to that. We have colleagues very interested in kind of biological processes and the math and the computing behind modeling tissue growth or morphogenesis. We have several colleagues very interested in kind of data and the statistical side of things, spatial statistics, how things are interconnected, things like correlations and data for kind of genomics and understanding predictions of diseases. And really thinking about, kind of the connection between models and given data and how to get kind of these parameters in these models for Professor Arnold. So another kind of key thing about WPI is, theory and practice through projects, but there's also a very strong interdisciplinary approach in our department. Some of our faculty, including Randy Paffenroth, interact with data sciences, chemical engineering, and they're doing machine learning approaches, thinking about reducing waste in chemical processes. We have strong ties to kind of the computing side of things in our department. So students will get the chance to use some of these high performance computing centers, through coursework. We have collaborations with faculty in other research labs across campus. So you can be in a math program, but be able to interact with biologists or chemists and do some really interesting work and see these applications in courses. Okay, and now Professor Blaze will take it away.
Okay, thank you, Professor Olson. I'll tell you about the WPI undergraduate experience, what it's like to study math at WPI. You probably have a sense already that we have a lot of flexibility with 4 terms per year. And you can collaborate with faculty in many different areas of research, a lot of the topics that Professor Olson just went over. In the first year, typically students focus on mathematics, science, and humanities or social science courses. So we'll talk here about what you would take in terms of math. So the first math you typically are dealing with is calculus. And so this is our calculus 1, 2, 3, 4, our standard calculus sequence. We'll talk in a minute about which one you would take. We also have our analysis sequence, which if you're interested in Calc 3 in A term and Calc 4 in B term, it's more of a, think like more of a math majors approach to calculus. You actually see more of the theory and the underlying structure of calculus in this version. But in any case, you would be taking a calculus placement test, which would help you decide which course is right for you. Really the goal of that test, which is a test you take at home, unsupervised, the only purpose it serves is to help you figure out which calculus course is right for you. After that, I guess with calculus, we also want to talk about advanced placement credit. Many people are wondering, what does your AP calculus credit get you? And so to talk holistically, there are 3 ways you can get calculus credit at WPI without taking a calculus class at WPI. One is college transfer credit. If you've taken or plan to take a course at a different college, you can get in touch with our registrar and we can figure out which calculus class that maps to at WPI. And then we have our AP policy and our retroactive credit policy. So first, our AP policy, there are 2 advanced placement versions of calculus. You have AB and BC. And so if you take the AB exam and you get a 4 or a 5, then you get credit for Calc 1 and 2. And then the natural thing to do is to start in Calc 3 in A term, Calc 4 in B term. If you get a 4 or 5 on the more advanced BC exam, that gives you credit for calculus 1, 2, and 3. And in that case, you start in Calc 4 in A term in a special cohort of students who have that AP credit. And then there's a special cohort of ordinary differential equations in B term, and then an advanced linear algebra course. Our regular matrices in linear algebra 1 is Math 2071, but Math 2072 is just a slightly more advanced version that's set up for this cohort that runs in our C term. So these are 2 very natural ways to come in and start your studies at WPI if you have AP credit. If you don't have AP credit, maybe you go to a school where there isn't AP or you don't have access to an AP exam, we have a retroactive credit policy. And this really comes up in conjunction with the calculus placement test. So if you come in and you decide to start in calculus 2, usually done when the placement test suggests calculus 2, but you don't have AP credit. If you take calculus 2 and 3 in your first year and pass them on the first attempt, then you automatically get retroactive credit for calculus 1. Similarly, if you start in calculus 3 and you pass it on the first try, and then you take calculus 4 and pass it in the first try in the first year, you automatically get retroactive credit for calculus 1 and 2. And so these are also very common for people to pursue. So that really gives us the lowdown on calculus. As a math major, an actuarial math major, or even if you're just considering one of those majors, or if you're just really good at math and you really love math, or if you're planning on a major that's considering a major that's very math heavy. These are all good reasons to take our Bridge to Higher Math course. This runs every D term, and really this course is there to help you learn to think like a mathematician. Once you start to take courses beyond calculus, you find yourself dealing with the idea of mathematical proof, conjecture and proof quite a bit. And so this is a class that really teaches you how to think that way, how to think in the formal terms like a mathematician, how to prove things, how to disprove things. And we really recommend this. It's not required, but we highly recommend it for all math and actuarial math majors because this really helps going forward. After the first year, this is when we start to get into things we call transition courses. So we have some 2000 level or sophomore level courses listed here that are meant to help you transition into being a mathematician. So these courses have some aspects of that formality, that mathematical formality of proof. And they also help you start to figure out what kind of math you're interested in. So it's important to recognize, Professor Olson mentioned we have over 40 faculty in our department. We have a large number of math courses. As a STEM school with a big math department, you don't just take all the math courses that run. You have a pretty rich menu of math courses, and you will end up taking some, but nowhere near all of them. And so as you're taking these courses, you want to be thinking about the kind of math that interests you. What's the kind of specialty that you want to have? And that leads you into your upper level courses. So your junior and senior level, 3,000 and 4,000 level courses, where you start to pick topics that you like. And in doing so, you're interacting with professors. You're learning more about these different disciplines. And then this leads you to a topic for your major qualifying project, your senior project, or MQP as we call it. So for the MQP, you would be working closely with a faculty member or faculty members. Sometimes they're team taught. Sometimes you would be working on your own, and sometimes in a team of students. It depends on the project. And this is equal to, in credit, an entire term. So it's one undergraduate unit or 3 courses. And recall that the standard course load for a WPI undergraduate for a term is 3 courses. It depends how it's structured. You may take all of this in one term if you're doing something, say, at one of our MQP project centers, or you may be spacing this out over multiple terms. It depends on how you set things up with your advisor. And again, going back to the slide that Professor Olson went over, there are a ton of different potential research topics. With so many faculty working in so many different areas, all eager to work with students on these projects, you really do have a lot of choices. And it's important to recognize that faculty members at WPI are eager to work with students on this. The mantra of theory and practice really is very central to WPI, and faculty members are very, very into this. And we all love working with students on these types of projects. Some MQPs result in publication, not all. And then also you see a link here. If you want to see some examples of MQPs, you can, if you just search mathematical sciences, WPI MQPs, this will come up and you can see some examples. We also have our Center for Industrial Mathematics and Statistics. So this is a group of faculty either in or affiliated with the math department who have strong connections with industry. And sometimes this gives opportunities for students to work on projects that are sponsored by industry partners. And these can be really cool and really fun. It's also important to be aware of our BSMS program. So BS for Bachelor's of Science, Master's for Master's of Science. In our department, we have 4 master's degrees: applied math, applied statistics, financial math, and industrial math. And many students opt to do this option where you finish your bachelor's and your master's in 5 years. And so typically a student would apply in their junior year, sometimes earlier. Some students do it in fewer than 5 years. It's possible. And then if accepted into this program, there's some double counting. So there's some undergraduate courses that count up towards master's degree requirements, and you can use some master's degree courses to count down towards undergraduate degree requirements. And so this is a really good thing to consider, because there's a lot of value of being able to knock out that master's program in that one additional year and go out either into the workforce with that master's degree under your belt. In terms of student experiences, again, you can see here we have a web page. I guess, well, we have links to these, so you can watch these videos of some of our students who will talk about the types of things that they're doing. In the top right, Forrest Miller, he was actually my peer learning assistant this past term for Calculus 3, which is another thing you can do as a math major. It's, you can work with professors formally and be paid to be a peer learning assistant for a course. Maybe just to speak about the student experience a little bit, the most recent MQP that I did, we had a couple of students. One was a math major, one was a math and computer science double major. I jointly advised with our colleague, Professor Stefan Sturm, and it was a project based on the idea of something called an ad impression. So think about if you go to a website and you're going to see an ad on that website. A lot happens before you see that ad. The way it works is you type in the URL, and then what's called an ad impression is created on your screen. And that impression, an ad will go there. But before it does, that goes to an auction. On that auction, it's a weird auction the way it works, but companies bid on that spot based on information about you. What's your operating system? What's your zip code? What can they tell about you from your computer? One of those companies wins that auction, and then they decide from one of their clients what ad to put there in front of you. And so in that MQP, we were looking at some mathematical approaches to make intelligent bids for one of these companies in that ad impression auction. And that ended up being a really fun project. So that's just one example to give a sense of the kinds of things students do. Okay, I think I'll kick it back over to Professor Olson.
Yeah, so lots of great things. You can check out our webpage that we have for kind of prospective admissions, student experience videos. You can get to hear about all the fun things that our students do for activities, and they're they're in the choir, they're in a running club, they're in the theater on campus, and all the kind of great things that they're able to do. And we're happy to answer any questions that you might have right now, or if you think of any later, you can feel free to contact us, or we have a MA-questions email address that you can also reach us at, but happy to answer any questions you might have.
Thank you both so much. And I guess we'll just kind of hang out for a minute just to see if there are any questions from any students out there, or, oh, we have something, hold on. Okay, so do you guys want, is it okay if I just read them to you and then you can answer? Okay, if I am getting concurrent enrollment for a Calculus 1 class with my local community college, would I get any credit from WPI? Well, Marcel,
So what happens? So typically when students take calculus courses or any math course elsewhere, there's some kind of credit at WPI. But what happens is you contact the registrar's office, and then they basically initiate a transfer credit procedure. And then we in the mathematical sciences department will look at the course that you took and figure out what it maps to here at WPI. And some the way that calculus courses line up with WPI calculus courses it varies across different institutions. So calculus 1 at one place might mean calculus 1 and 2 at another. So it's handled on a case-by-case basis, but we handle tons of these. So it's a completely standard thing for people to get credit.
Great question. Yeah, and I will also say too, and I'll put a link in the chat for everybody out there. We do have a link on our website to all of our transfer equivalencies to date. So all you have to do is just click on the college if it's already been determined. There's a chance that, maybe it hasn't been looked at yet, and that's possible. But if you're curious to see what classes are being used or have already been evaluated, I can go ahead and put that in the chat for everyone. So I will put that link there.
There's a lot there. You'll
Yes,
see that.
there's a lot of them. So
There's been a ton of these things.
there's a lot of them. And we, for incoming first year students, the admissions office helps with that as well. So if you have any questions, feel free to reach out to the admissions office too. It looks like we have a few more questions. So next question is, what percentage of classes are taught by postdocs or grad students in the math department?
So that's a great question. In general, we have very few classes taught by grad students. Our graduate students are primarily doing review sessions or discussion sections, holding office hours, assisting and kind of providing extra contact hours. But the classes are generally taught by the professors or kind of full-time instructors or professors at WPI. We occasionally have a graduate student sometimes teach in the summer, but they're usually already have their master's degree. For postdocs, we have a few postdocs that we have that are teaching at WPI every year. Postdocs do have their PhD. They already have their formal training in kind of pedagogy and teaching courses, and generally also have experience from prior institutions. But I'd say, so, we have a faculty or, full-time instructors of 45 or so, and we have 4 postdocs. So the number of postdocs is a lot smaller than the number of faculty. So you could potentially have a course with a postdoc.
Thank you. And then it looks like we have one more question. Could you also comment on how many general education requirements there are?
Sure. So we have 15 units required in total to graduate. And what we typically see is 10 of those units, and make sure I'm getting this right, defined by an individual program. And so those would be your major specific requirements. And then you have 5 units that are not major specific. So you have 2 units, humanities and art, 1 unit IQP, which is your intermediate qualifying project or interactive qualifying project. Sorry, that's something typically done in the junior year. Then we have 2/3 unit social science and 4/3 unit other or elective. So there are more general requirements beyond just the major.
Yes, that's a great answer. Awesome. Well, it looks like that's the end of the questions that we have right now, but I would definitely, if anybody out there has any more questions, feel free to email the math department, email admissions. And also, I want to take a quick second to just thank Sarah and Marcel for being here with us today. We know it's fall break and they have a lot going on. So I just want to say thank you to them from the admissions office. And if you are interested in any more of our other events that we have coming up for the fall, feel free to visit our website. And I am going to put the website in the chat so that I don't forget to. And I will do that right now. Okay. And yes, with that, I will say thank you so much. This is also being recorded, so it will be posted on our website within the next couple of weeks. So thank you all so much for being here, and have a great night, everyone. Bye.
Thanks, everybody.
Thank you.